A particle moves according to a law of motion where s is equal to f of t and t is greater than or equal to 0, where t is measured in seconds and s is in feet. The function that we have here, which is the position function, is equal to the cosine of pi t over 4, where t is less than or equal to 10. So in part A, what we want to be able to do is we want to be able to find the velocity at time t, meaning that we want to find what is the derivative of this position function. So the velocity is the derivative of the position function. And so the derivative of that function is going to be, well, the derivative of cosine is going to be negative sine of pi t over 4. And then what is the derivative of the inside function? So the derivative of pi t over 4 is equal to pi over 4. So therefore, this is equal to negative pi over 4 times the sine of pi t over 4. So now what we want to do is we want to be able to find out what is the velocity after 3 seconds. So we want to find out what is v of 3. So we're going to plug it into the velocity function that we found. So it's going to be negative pi over 4 times the sine of, that's t is going to be 3, so it's going to be 3 times pi over 4. And so we know that the sine of 3 pi over 4 is equal to the square root of 2 over 2, which is equal to negative pi times the square root of 2 over 8, which is going to give us approximately negative 0.56 feet per second. So when is this particle at rest? Well, it's at rest when we let the velocity function v of t, which is equal to 0. And that velocity function is negative pi over 4 times the sine of pi t over 4, and that's equal to 0. So if we divide both sides by negative pi over 4, then we end up with the sine of pi t over 4, which is equal to 0. Okay, and then what we're going to do is we're going to take the inverse sign in order to solve for t. So we have pi t over 4, which is equal to the sine inverse of 0. And so here we're looking for the angle whose sine is 0. And so the angles where the angle is 0 are the following. So we know that it's at 0, we know at 180 degrees, and we know that at 2 pi as well. And so we can keep going on, but we're going to solve for t here, and we're going to divide each of these by the reciprocal of pi over 4. So 4 over pi times 0 is going to give us 0. And then 4 pi over pi is going to give us 4. And then 4 times 2 pi over pi is going to give us 8. So therefore, those are the seconds, 0, 4, and 8 seconds. So now what we want to do is we want to figure out when is the particle moving in the positive direction. So whenever the particle is moving in the positive direction is when we let the function v of t, the velocity function, is greater than 0, which means we have negative pi over 4 times the sine of pi t over 4, and that is greater than 0. So using these numbers from 0 to 4 and 4 to 8, what we can do is we can look at these as intervals. We have an interval that goes from 0 to 4, and then we also have an interval that goes from 0 to 8. And then we're going to, from 4 to 8, excuse me. So 0 to 4, and then 4 to 8, according to what we got here. Okay, so we can plug in a value into this interval, into that inequality, to see whether it's going to be positive or negative. So if we plug in, let's say 1, so if we have negative pi over 4 times the sine, if we plug in 1, so if we let t is equal to 1 and then plug that in, then we're going to get the sine of pi over 4, and is that greater than 0? Well, that's false because this is going to be negative, and so therefore this is a negative in that interval. And then if we look at the interval between 4 and 8 and we pick a value in there, so let's say t is equal to 5, and then we plug that into negative pi over 4 times the sine of 5 pi over 4, well, that's going to be greater than 0. So therefore this is true, which gives us a positive result, and this is false. So therefore, when is the particle moving in a positive direction? Well, we saw that it gives us a positive in this direction, which is in the interval between 4 and 8, or we can say that t is going to be in between 4 and 8 for when the particle is moving in a positive direction. Okay, now the next thing we want to do is we want to then be able to find the total distance traveled during the first 8 seconds. So since we know that it's going from 0 to 4 and 4 to 8, that means we have 2 intervals. So the intervals that it's going is from 0 to 4, and then 4 to 8. And recall that the position function, which was s, was equal to the cosine of pi t over 4. So what we want to do is now we're going to find the distance from f of 4 minus f of 0 into the position function. So we want to take the cosine of, that's 4 pi over 4, which becomes the cosine of 1. So that's 4 pi over 4 minus the cosine of 0 pi over 4, which ends up giving us the cosine of pi is negative 1 minus the cosine of 0, which is 1, which gives us negative 2, and the absolute value of negative 2 is 2. And then we want to find f of 8 and subtract f of 4. So that means we have the cosine of 8 pi over 4, and that's minus a negative 1 from our previous result there. So the cosine of 2 pi is positive 1, and then that's plus 1. So 1 plus 1 is going to give us 2. So the total distance is equal to 2 plus 2, which is equal to 4 feet. Okay, so now let's go ahead and draw the diagram from this information that we got here. So let's go ahead Okay, so let's go ahead. Let's say here this is 0. We know that this is representing our position function. So what happens when t is equal to 0? Well, we saw that when t was equal to 0, we got 1. So when we put in f of 0, we got 1. So therefore, at 1 here, when t was equal to 0, we know that s was equal to 1. And then when t was equal to 4, and we plugged it in, we got -1. So that means that the position is now going in this direction. So therefore here, when t was equal to 4, the position was at -1. Or, I guess, if you want to clean that up there a little bit, we know that it is then going to be here for when t is equal to 4, s is equal to -1. And then what happens when t is equal to 8? Well, when t was equal to 8, we got a +1. So it was going in this direction, and then it was going back to this direction. And that was when t was equal to 8, we said that s was equal to 1. So what happens when t is equal to 10? Let's just see what happens from there. If we let t is equal to 10, and then we plug it into the position function, we get the cosine of 10 pi over 4, which is equal to 0. So that means now it ends up going back to the position of 0 here. So when t was equal to 10, we saw that the position was heading back to 0. Now we want to be able to then find the acceleration at time t and after 3 seconds. So we know that our velocity function was equal to -pi/4 times the sine of pi t over 4. And so the acceleration is the derivative of the velocity. So that means that we have -pi/4 times the cosine of pi t over 4. And then we got to multiply it by the derivative of what's inside the parentheses. Well, the derivative of pi t over 4 is pi over 4. So now we can then say that pi over 4 times -pi over 4 is going to equal -pi squared over 16 times the cosine of pi t over 4. And so therefore there is the acceleration function. And now we want to find out what happens after 3 seconds for the acceleration function. So that's equal to -pi squared over 16 times the cosine of, we're going to let t be 3, so it's going to be 3 pi over 4. And the cosine of 3 pi over 4 is negative square root of 2 over 2, which is equal to pi squared times the square root of 2 over 32. and this is approximately 0.44 feet per second. Okay, so now that we found the acceleration at 3 seconds, which is 0.44 feet per second squared, we want to then graph the position, velocity, and acceleration functions for when t is in between 0 and 8. But if we go back to the beginning, it says that t has to be less than or equal to 10. So what we're going to do is we're then going to instead of using the 8 here, we are then going to make this less than or equal to 10. So let's go ahead and graph our functions. So if we graph our function, we have the position function, which is the cosine of, that's pi, we'll call that x, and divide that by 4. And then the velocity function was negative pi divided by 4 times the sine of pi x divided by 4. And then we have the acceleration function, which is negative pi, and that's squared, divided by 16 times the cosine of pi x divided by 4. Okay, so if we take a look here, we can see that we want to make sure that we're going from -1 to 10, so we'll go to 11 here. And then we know that our sine's going between 1 and -1 in addition to the cosine. So let's go ahead and then copy this graph so we know what's happening between 0 and 10. Okay, so the blue is the position function. And the green is the velocity function. And the purple is the acceleration function. So what we want to be able to do now is find out when is the particle speeding up and when is it slowing down. So if we take a look here, the particle is speeding up when the velocity and acceleration have the same sign. So if we take a look at the interval between 0 and 2, so here's the interval between 0 and 2. Okay, we see that the velocity function is negative, it's below the x-axis. And we can also see that the acceleration is negative. And since they're both the same sign, we can see that it's speeding up between 0 and 2. And then also, if we take a look between 8 and 10, okay, we can see that the velocity function is negative and the acceleration function is also negative. So those are both the same signs. So again, that's when the velocity and acceleration are both negative. And then also, if we take a look at the interval between 4 and 6, we can see that the velocity function is above the x-axis, so therefore you can see here that it is positive, and then the acceleration function is also positive. So therefore between 4 and 6 it's also speeding up, and that's when the velocity and acceleration are both positive. Okay, so now what we want to do is determine, okay, when is it slowing down. And it's slowing down when the velocity and acceleration have opposite signs. So if we take a look at the interval between 2 and 4, okay, we can see that the velocity function is negative and the acceleration is positive. So in between 2 and 4, and then also between 6 and 8, we can see that the velocity function is positive, whereas the acceleration function is negative, and therefore between 6 and 8.